So in this video we're looking at the formation of complex ions and the different types of complex ions that can form. So if you take copper sulfate, it's got 5 waters of crystallization, it's a solid, blue crystalline solid, and you dissolve it in water. Before we just said there's copper 2+ ions, but actually what we're forming is this ion here called a complex ion. And this is a copper with 6 waters actually covalently bonded to it. So a copper 2+ ion with 6 waters covalently bonded to it to make a whole ion with a 2+ charge. And this is what it would look like. The waters are actually donating a pair of electrons. This is different to hydration, where the waters are attracted to, let's say, a sodium ion. They're actually donating the electrons. They're forming dative covalent bonds. And we can tell they're forming bonds by the bond angle in the water. It changes. That lone pair becomes a bonding pair. And so we have 3 bonding pairs, 1 lone pair, to make a bond angle of 107 degrees rather than 104.5. So we actually got dative covalent bonds, and in this particular case those dative covalent bonds are known as coordinate bonds. The waters take on the role of ligands. A ligand is a molecule or an ion that donates a pair of electrons to a central metal ion to form a coordinate bond. So this copper 2+ ion has 6 coordinate bonds. So we say its coordination number is 6. The coordination number is 6, which is the number of coordinate bonds. So we have ligands bonded to a central metal ion. The ligands are forming coordinate bonds to the copper metal. They're actually donating, each ligand donates a pair of electrons to form an actual covalent bond. And that's what's known as a complex ion. There are different types of ligands. Water is a monodentate ligand. Monodentate ligands donate 1 pair of electrons to a metal ion. All these are monodentate ligands. You notice the first 2 are neutral, the next 3 though are negative, and that will affect the overall charge. So for example, if you had an Fe3+ ion and 6 hydroxide ions, the overall charge will not be just simply the metal ion charge like it was before, it will be 3-. In the previous example, water was neutral, so it doesn't affect the overall charge. But the overall charge of complex ion has to take into account the charge of the individual ligands and the metal ion. Another type of ligand is the bidentate ligand. A bidentate ligand can donate 2 lone pairs of electrons. A very common example of this is 1,2-diaminoethane. Quite often that's abbreviated simply to EN because it is used so often. So the bidentate ligand can form a covalent bond, or this particular one can form a covalent bond with this nitrogen and this nitrogen. So if you see here, there's 1 bidentate ligand there. It's bonding here and here to the essential transition metal ion. Here's another one bonding here and here. Here's the 3rd bonding here and here. This is still 6 coordinates. It's still 6 coordinate bonds, but it's 6 coordinate bonds with done by 3 ligands, and each ligand is bonding twice. Another example is the ethan dioate ion. Here it is bonding to a platinum ion. The platinum ion would have been 2+. It says 2- here because you've got 1-, 2-, 3-, 4- altogether. We don't put individual minus signs on the ligands. We add it all up and put up the overall charge here. So we've got a total of 4-, 2+, so 2- altogether. There are 3 shapes you have to be aware of when it comes to complex ions. First one we've seen already, octahedral. So whenever there's 6 coordinates bonds, we have an octahedral shape. 90 degrees bond angle between the ligands, just like you saw for SF6 in the first year, same shape, octahedral. If it's a 4-coordinate complex, there's 2 possibilities, tetrahedral and square planar. Tetrahedral is exactly the same shape as you saw before last year. The bond angle is 109.5. And this is the more common of the 4-coordinate complexes. The less common is a square planar. So just imagine the 4 corners of a square being taken by a ligand. Planar, so it's flat. And here the bond angles are 90 degrees. This is seen quite a lot with platinum complexes.